Welcome friends. In this video we are going to see the building design by using STAAD Pro, and we will compare our results with manually calculated. These are the given data. G plus 3-story building. These are the results that I have calculated manually, and we will compare with our STAAD Pro results. Okay. So let's begin to our project of G plus 3-story. So we will first create the plan. Go to the XZ, so we can create the plan here. It's easy. First select the node here. Yes, and we will copy this node at a distance of 6 meter. The horizontal distance is 18 meter. Column to column distance is 6 meter. Hence, we are pasting it 3 times. Again 6 meter. I have also made the videos manual design of building. You can check the playlist so that you will also get the knowledge related how manually building we can design. And software is, yes, I am going to make the video, so that will also helpful for you. Now we will translate this in the Z direction at a distance of 6 meter. Click on link steps. Okay, now we will translate this at a distance of 4 meter in Z direction. Once again, only one step. Now once again at a distance of 6 meter, only one step. Okay, now we will repeat the nodes. Okay, sorry, there are still secondary beams we need to draw. So I am going to select the beams. All these manual design videos are in Hindi language, so you can go there if you feel difficulty in English. Software videos I only made in English, other site videos and other videos are in Hindi. So I have translated repeat at a distance of 3 meter. So all this becomes one-way slab and the middle portion become the two-way slab. Now these are the secondary beams that I have just translated at a distance of 3 meter. Hence I am just selecting the nodes below which there is a column. All these are secondary beams, those where I don't selected. So you will know how to give the command of secondary beam. So I am just selecting the nodes where column position is there. So translation repeat in Y direction. We will translate at a distance of 3 meter -3 because in the downward direction. Link step. Okay. Now I will just check it. Yeah, comfortably. Now we will translate this at a distance of, I think its floor to floor height is 3.35 meter. The third line, floor to floor height is 3.35 and number of stories are 4. So above which we have to translate this. Some other data is also given there. So if you want for your project in college, you can use it. So we will select this floor and we will translate repeat in Y direction. Spacing is 3.35 meter and number of steps will be 4, and we will not link the steps here because if we link, all the columns will get connected because and we don't have the columns at every position. You know where are the column positions. So now you can see here. We will again select those nodes where the columns are. and then we will translate repeat. These are the secondary beams. Since there is no any column, these beams rest directly on the other beams, and then those beams rest on the, that means secondary beam resting on primary beam. Okay, now we will again go with Y. Default spacing will be 3.35 meter and the number of steps will be 4, and we will link steps. Okay. Now you can check here when we will go in the 3D view. Yeah, our modeling part is done, I think. Now we will assign some of the properties of beam and column. So go to the define menu, and the rectangular shape beam and column, hence we will give the select the rectangle 0.230 and 450. Its width is 230 and the depth is 450. We'll add it, and these are in meter, hence I have written in 0.450. I just check what are the sizes for column in the analysis. Let me check. Yeah, just see, check that these are 0.6 by 0.3. Now add. Now we have to assign this property to our structure. Go to select beam parallel to X, beam parallel to Z, and assign to selected beams. Assign, are you sure? Yes. And now we will go for select beam parallel to Y. Yeah, okay. Assign, are you sure? Yes, okay. Now we have assigned the properties. Now we will go to the specification part that I have told you that secondary beams are there. So we have to release the movement. So go to the beam. Yeah, these are secondary beams. Now go to beam and release the movement in MY and MZ direction. Click there, click on add. Now once again beam. Now select end, means start and end location movements has been released. Now select all the secondary beams. We have 6 secondary beams in our plan, and we will give the command that assign to selected beams so that movements will get released in the start and in the end. Okay, now these beams will act as a simple support, simply supported beam. Now go to the support. We will add a fixed support. Yes, just add. Select the node, bottom nodes. Yes, okay. Now we will, the most important part is of load and definition. So see it carefully, just be careful while watching, because the most important part is loading. Okay, here I have add the dead load and live load case. Now before going to loading, I have very simple method of giving the floor loads. So first select the floors where the same loading condition is there. These all floors have same loading condition, that's why I have selected. I go to the plan view. Now I will select all one-way slabs together and all two-way slabs. So select all one-way slabs. These are one-way slabs. Now press Ctrl G from your keyboard and give the name here one way. and all these are floor, typical floor, not the terrace floor. Terrace floor the loading is different, hence I have made two groups, one way floor, and select here floor. Okay, now associate, click on, yeah, now all we have associated. Now we will select, make another group of two-way, means this is two-way distribution, hence two-way, and these are the floor, typical floor, those have same loading. I have selected the two-way, associate. Okay, you can check here by clicking on highlight button that they are selected or not. Okay, now come to the whole structure. Sometimes the terrace floor has a different loading. It may, in our condition it has, so I have selected the or made the two groups. Now I will create here again one way and two way, but I will give the name as one way terrace. So I will while giving the loading I will be comfortable. Now click on associate. Now you can check just here, create two-way, means two-way distribution with terrace floor. The loading is of floor and terrace is different. That's why I have made two groups. If you have same loading, you can only create two groups, one way and two way, and select whole building and its plan. Okay, now close it. Now go to the dead load, whole structure. Yeah, okay, first whole structure. Now go to the dead load. First we will add the self weight, actually not member load. First we will add self weight. That means whatever column beams are there, their self weight we will add. Now we will add the floor loads. Now go to the member load, and let's check the loading here. Yeah, the self weight of the slab, yeah, the depth of slab we have assumed 115 millimeter, hence its dead load becomes 2.875 millimeter. Now in that we need to add the floor finish load and the live load. I am combining in the same. I am not considering the live load case, I will delete it later. You can create two cases, it will be better for you. Here its self weight is 2.875 and the for floor finish is 1 and live load is 4, so I have to add 2.875 plus 1 plus 4. Okay, and that loading I have to give. I'm just, yeah. Now go to the floor load and select the group. Now minus that intensity 7.875. Now click on one way because we want one way distribution and we have selected there one way floor. Okay, now click on two way. Now we don't need one way distribution because distribution is different for two way and one way. Now add. Okay, now for the terrace floor the intensity of loading will change. Okay, that roof floor finish is 1.5, live load is 1.5. we can check in the our slide also. Yes, here roof finish 1.5, live load 1.5 plus that dead load that I have shown you previously. We have to combine all these. You can make dead load different, live load different. That case will be very comfortable for you. Okay, so that summation becomes 5.875 and one way distribution, hence one way, and for two way we will unclick and that will become the two way distribution, and our loading part is finished. Yeah, I delete the live load case, but you don't. You make dead load and live load differently. Now we will give the wall load. Okay, there are two walls. One is internal, one is external. I think it's better to go for member load. Yeah, you can see this is the way you can calculate the dead load of the masonry wall. Floor to floor height minus the depth of the beam. So you will get the clear height of wall, and that is 9.15. Yeah, it's just go with, yes, member load. Uniform force, yes, minus 9.15. Add, these are internal walls having different thickness, and external wall is having different thickness. We have calculated there also, and the value is minus 14.03. Now add, close. Now for internal wall, select all the internal beams, and for external, select all the external beams. That is simple. Now I am here selecting all the internal beams where internal wall is there, hence that loading is there. Yeah, I think I have selected all internal beams. Yeah, these remaining are the external beams, so external wall will be there. Okay, now we will give the external loading, external wall loading on the external beams. So select those beams. Yeah, now I'm just assign to selected beam. Assign, are you sure? Yes. Yes. Save. And now I think loading part is done. We will add the factored loading, that is 1.5 times. Define combination 1.5 times dead load. Give the factor 1.5. Now add. Yeah, its dead load case will be there, and second case will be 1.5 dead load, no problem. Close. It's better you will make two different cases, dead load and live load. Now we will analyze. Analysis, print, add, close, analyze, run, analyze. It will take some time. Now we will compare our STAAD results with our manually calculated results. Okay, I'm just selecting 1.5. Actually it will take both the cases. Now yes, here is our results that we have calculated manually. You can check the videos. You can click on I button, or you can go to the playlist of designing building manually. Now select this floor, because this floor I have done the analysis of the beam. So go to the top view and go to the beam. Yes, this particular beams I have analyzed. Yes, select the combination case, and now you can see the support moments at 140 and 151. Okay, now we have to check what we have. Yes, we have 132 and 150. That is very much close, I think. Yeah, we have to see what are the changes there. That's why the results are slightly different, but the error is not big, I think. Now you can check the shear forces also, that have 156 and 160. and yeah, we have manually 149 and 155. So these values are so much closer to our manual calculation. Yeah, this changes because I think we have given the terrace parapet wall, we have given whole here no issue with the parapet wall because we are now considering the floor. This is the simple support beam, and that's value I have calculated 237, that is mid span, and manually that value has 228. So there is only difference of I think 9. Yeah, we forgot to check. Yes, click here, go to shear bending. Now we will check the mid span movement. Just scroll down to the center where the maximum point is there, and you can check under the value of EMZ. It's I think near to 90-91. Yeah, you can see right is as 91 or 92. Yeah, I have written 92. That is also very close. Now we'll check the reaction. I also made video on how to calculate the load coming on the column and how to reach to that value 2285. So difference is not too much. You can see the error by comparing those values. To check the reaction, we need to select the node. I think go to whole structure. Let's select all the nodes. Node cursor we have to select, yes, and new view. Okay, go to the plan view, and yeah, this is the node. Yeah, that is I have manually analyzed that particular node. So the reaction is there is I think it's 3018. Yes, I think we have calculated manually. It's about let me check. Yeah, it's 2285, and if we take for footing it's 2325. Yeah, this is because I think we have taken the extra load on the floor. That typical floor we haven't applied the wall load of 1 meter. We have applied I think full length of the wall. That's why I think that loading gets higher. I think that is the only reason, I think, because of that loading is here. Okay, now we'll go to the design part. IS 456, you can choose your own country code. Now select parameter. I'll just give FC, compressive strength and yield strength. Even okay. Yeah, I think M25 grade is there. Let's check. Yeah, no, it's M20. It's M20 and FE415. So we have to give M20. Add FY main 415. Yeah, okay, add it, close. Now we will assign to view. Yes. Now we will go to the define command, design beam, design column, take off, close. Design beam means all the horizontal member, that is X and Z, will act as a beam. hence so that because of this command STAAD Pro will come to know that these we have to design as a beam, and all the vertical members, that is select Y parallel to Y, will be column, hence it will design this as a column. Okay, now you can go for run analysis. Okay, go to post processing mode. Yes, STAAD Pro give n number of results, and if you want to know how to make a report, go on checking the how to make the report. In the STAAD Pro playlist there is one video. I will just check the results. Here concrete design, you can see the AST, number of bars and the size of the bar. It calculates the area of steel correctly, but while giving the bars, if it is better, you will convert into the bars, because STAAD Pro, this software not gives the right way, means it gives 10 number of 10 bars or 20 bars of 10, so you can convert according to your way. So we will compare our result. Yeah, as you can see, the reaction is more, hence the area of steel is more. If we reduce that load, our reaction will come again lesser and the AST will come again lesser. Okay. Now you can double click on the beams and you can check the design concrete. 4 bars of 20 mm, 4 bars of 20 mm at the top, 10 bars of 10 mm. So you can convert into 16 bars, 16 mm bars of 4 or 20 bars, 20 mm bar. You can convert according to the way you want. Okay, so that's it from the video. I have also made, I have told you that seismic analysis I have compared with IIT document. You can check there these videos, and truss analysis is also there. So click on the, I have giving the playlist at the end. You can at the end screen, you can click there. Okay, thank you for watching the video. Thank you from Real Civil YouTube channel. Please subscribe, share, like the video. Thank you.